Hey, my name is Ben. Thanks for stopping by. Today we're going to be talking about floating neutrals versus bonded neutrals when it comes to generator applications like this generator that I have right behind me here. So I'm just going to show you how this particular generator is set up at first, and then we're going to go through several different aspects of kind of understanding and fleshing out that concept of whether or not the neutral should be bonded inside of your generator or not. So the generator we're looking at today is just this little portable propane and gasoline generator that I've had for quite a while and used it a couple of times. And in order to figure out whether or not you have a bonded neutral, one of the best places to look is just in the documentation that came with the generator. It should say somewhere whether or not the generator is bonded. So what we're going to actually do is I'm going to show you guys the electrical wiring diagram, and we should be able to take a look at that and see whether or not the neutral is bonded. Oftentimes if you have a floating neutral generator though, it'll say somewhere right on it that the generator is a floating neutral generator. So right here we have the wiring diagram for this particular generator, or it's the one that was located in the user manual for this one anyway. And if we look at the way this is all laid out here, you'll see right here, here's our main winding, which is supplying our 240 volts, and it's 120 volts from each half of the coil. So the center tap of that winding is where our neutral is derived from, where the neutral comes from. So you can see right here we have this wire that comes up and it says W right there, and that's for a white wire, and then it right here connects on and continues and ultimately connects to the neutral prong on the different receptacles. And then it also branches off right here where this yellow highlighted point is, and this comes down and is bonded to the ground. If we follow this green highlighted wire, you'll see that this connects to the grounding prong of both the 240 volt receptacle and the 120 volt ones, and it ultimately comes over here to where we have a grounding point on the actual frame of the generator that we can connect this to a grounding rod. So right here, between here and here, this is our basically jumper that's bonding our W, or our center tap of that transformer, to ground, and it's referencing it to ground. So what I want to do now is I'm going to show you where this jumper is located inside of my generator. So on the end of your generator, typically you'll have a cover like this that you'll just have to remove in order to inspect whether or not your neutral is bonded. There is another way to tell whether or not your neutral is bonded, and I'll show that to you here in just a couple minutes. But we're just going to start by looking at the actual wires. And if you wanted to make your generator a floating neutral generator, which is something we'll also talk about a little bit later, this is how you would do it. And actually Champion, and I don't know if there are other generator manufacturers, but there are a few generator manufacturers that actually allow you to and show you how to separate the neutral from the ground in order to make your generator be a floating neutral generator. Okay, so here is what we are looking at in that wiring diagram. You can see we have this white wire right here, and it comes from down in here. This is where that white wire lands, coming from that center tap of the windings, and it lands right there. And from right here to right here is where we would typically see our jumper. Now, I actually already knew this, but basically this generator actually does have a floating neutral, which is very surprising because it doesn't say it anywhere. Basically what we have is some bad documentation, and I think that's just part of when you purchase Chinese generators. They don't have great documentation. So let me just prove to you that this is not bonded right now, and we're just going to go from this terminal right here, which is our neutral, to ground, and you'll see that we have no continuity. It's reading like it's a capacitor, but there is no continuity there. If we just switch it into ohms, it says open lead. And if I just go across all of these, just to make sure, every single one of them is an open lead. So that means that this particular generator is not bonded. It is a floating neutral generator. Now, I am pretty displeased with the documentation from DuroMax on this particular one. I actually thought that this was a bonded neutral generator, and there are some safety concerns or things to be aware of when you're working with a bonded neutral generator versus a floating neutral generator. So that's what we're going to kind of go through next. I'm going to show you one more way as to just how you can tell between a bonded neutral generator and a floating neutral generator without having to take that end cover off to look inside of there. So here we have our electrical tester, and we're just going to go ahead and verify whether or not this is a bonded neutral or floating neutral just using these receptacles here. And the way we can do that is just to take one of our prongs and put it in the neutral side of one of the receptacles, like that. So now we're basically connected to the neutral, and then go ahead and test to the grounding point of the generator. And you can see right there, it's telling us open lead. Except for the grounding prong. If we check from the grounding prong, you'll see that we do have continuity. So if this were a bonded neutral generator, we would have gotten continuity from the neutral to the ground because they're basically connected together, which I'm going to show you a little bit later here with them bonded so that you can see that in a little bit more detail. Alright, so we have a floating neutral generator we eventually established. Even though the instructions were not clear and the wiring diagram showed that this was a bonded neutral generator, it's actually a floating neutral generator. And actually, I found on their website in the Q&A section, they do actually answer somebody's question and say, oh yeah, it's a floating neutral generator, but nowhere in the instructions does it say that. So, buy a nicer generator. Get a Honda or something else that's not a cheap Chinese one like what I have here. So now that we know we have a floating neutral generator, we're going to simulate a couple different things, starting by simulating a short circuit. So here I have a just appliance cord that I salvaged, and I'm going to create a dead short between the hot leg of one of these 120 volt plugs to the frame of the generator. So it's as if we had a bare wire that somehow came up against the frame of the generator, and I'll show you what happens. Obviously, optimally we'd want the generator to trip the breaker when that happens, but I don't think that it's going to do that because basically the frame is its own thing. It's separate from everything else. Now, the generator is still not grounded separately. It doesn't have a ground rod attached to it, but we're going to simulate that next. So we'll start with this. We've got our breaker turned off right there, and we're going to just attach our appliance cord right there, and then we're going to connect our hot wire to the frame of the generator. So we're just going to do that here. We could actually do it right here on this ground, but I don't think I'm going to do that. I think I'm just going to pinch it in this handle here. Alright, like, oh, it cut it right off. Just like that. Alright, that's pinched in there now. So as soon as we apply power to this, it's going to have a dead short of 120 volts directly to the frame of the unit. So I'm going to be really cautious while we do this test. So what we're going to do is we're going to start the generator, and I'm going to flip the breaker on so that we have power coming through this cord here, which is then shorted out to the frame of the generator. And then we're going to check for voltage from the frame of the generator to ground, as well as the neutral prong, this left prong of this 120 volt plug, to the frame, just to see how much voltage we have on the frame of the generator, and also just to see if that breaker will trip. So here we go. So we're going to put the breaker on. Now we're going to check for the frame to neutral. So there you saw how we had 120 volts from the neutral prong to the frame of the generator. But from the frame of the generator to ground, we actually had 0 volts, which is really interesting and basically what that means is this is kind of like a separately derived system. We have power coming from this generator, but there isn't anything attached to the ground. Nothing. Other than like the feet of the generator that are sitting in the grass. That's the only thing that's really connecting the system to anything. So when we connected 120 volts to the frame of the generator, that little bit of connection that it had with the grass and the dirt basically was referencing that portion of the windings of the generator to ground. So we had our 120 volts that we would typically measure from the dirt to 120 volt prong. It was 0 because that 120 volts was referenced to ground. So it's kind of confusing, but this is kind of a good example of that. So the reason this creates such a hazardous situation is that if you were to have a metal framed appliance like this fan right here, where the frame of the appliance is bonded to the ground prong, so we have our ground prong right here on our appliance. If we were to go ahead and just check for continuity from the ground prong to the frame of the unit, we do have continuity there. So you can see how this creates a hazardous situation where we have 120 volts on the frame of the generator, which if we were to plug in this fan, then would transfer that 120 volts onto the frame of the fan, or vice versa. If there were to be a short in the fan over here, it would send power back through the grounding prong and to the frame of the generator. So how do you fix this? What is the solution to having a generator with a floating neutral? We just saw what happens when you short 120 volts to the frame. Basically energizes the frame and energizes any grounded appliances that you may attach to it, or vice versa. So how would we make this safe? You would kind of think intuitively that you would just attach a ground rod, which we have an 8-foot ground rod driven right there, and we have attached it to the ground terminal on the generator. I have my appliance cord plugged in there. 120 volts will be on this black wire, and I'm just going to short the black wire out to the frame of the generator, and the frame of the generator is connected to that ground terminal right there. So 120 volts straight to ground basically is what we're going to be doing, and it should trip that breaker, or that's what we want it to do. My prediction is that it will not trip the breaker, but I'll just show you. So here we go. We'll go ahead and start it up. Our breaker's turned off right now. We're going to go ahead and turn on our breaker. So we have power now here. So we're going to go ahead and touch the end of this wire, which has 120 volts on it, to the frame of the generator. You see that nothing happened. Let's try it down here. Nothing. So as you just saw, having it grounded made absolutely no difference in clearing the fault. We had a direct fault, 120 volts to the frame of this generator, and it did not trip. So that's why everything comes back to being bonded. That's why bonding is so important. You have to have the neutral of your system bonded to the ground of your system somewhere, so that you have a fault current path. Because the electrons want to return to the source. Ground really has nothing to do with it other than the fact that ground happens to be a conductor. So when we shorted out 120 volts to ground, it was sending 120 volts to that ground rod right there. And it didn't really care, because there was no way for the electrons to go into the ground and come back to this generator, because there was no connection. There was no other connection. It was basically just sticking one wire into the dirt. It does absolutely nothing unless that system is already connected to the dirt. Oh man, this feels confusing. Doesn't it feel a little bit confusing? It does feel a little bit confusing. With an ungrounded system, when the first phase or the first hot conductor comes in contact with any object, whether it be the ground or the metal frame of a building, nothing will happen, because there's no way for the electrons to go out into the ground and back, or into a metal structure and back. A fault doesn't really occur until the second live conductor comes in contact with the ground. This is hard to explain, actually. So there's an easy way to simulate having the neutral and ground bonded together. You see this cord that we have plugged in right here, you can see we have both the neutral and the ground wire there. If we just twist those guys together, we have created a bonded neutral generator just like that. Now, I'm not saying that that's the correct way to do it or that you should use that as a solution, but that's basically the exact same thing. Right here, connecting that neutral and ground together is the same as if you had connected it in that side cover. So we'll take our multimeter, put it into continuity mode, and we'll just check from the neutral prong, which is right here, to the frame of the generator. And you can see right there, we have continuity. So our generator now has a bonded neutral. So I'm going to simulate what happens with a bonded neutral generator. It's grounded and everything. Now if we go ahead and short that 120 volts out the same way that we did earlier, what's going to happen is it's going to be a direct fault and it should trip that breaker almost immediately. I don't really want to do this, but I'm going to do this for you guys so that you know that I'm telling the truth. Here we go. So that is the gist of it. You can see how having the frame of the generator bonded to the neutral and having the ground bonded to the neutral allows you to have a return fault current path so that when something shorts out, it will disconnect, because that's the primary goal of overcurrent protection, is shutting the power off as quickly as possible once a fault has occurred. So if you had a floating neutral generator and you were using it exclusively with extension cords, you could have a direct short, the hot to the ground, and it would not trip the overcurrent protection. So you can see why that is not a good thing at all. Obviously, if you have a short from the hot to the neutral, then it will trip. But essentially, in the generator, you want to have your neutral and your ground tied together if you're going to be using your generator exclusively with extension cords. Next, we're going to talk about why you want a floating neutral generator. After all that talk of why you don't want one, I'll show you why we do. Okay, for those of you guys who are new to this channel, if you do me a huge favor, hit that subscribe button and click the bell to be notified about future videos. 90% or more of the views that I get on my channel are from people who never subscribe. And I totally understand it. A lot of times you just want to watch one video and get on with your life. But if you find value in this content and you would like to see a little bit more in the future, do me a favor and hit that subscribe button. We are approaching 100,000 subscribers, which is awesome, and so I'd appreciate it if you help us hit that goal. Hopefully we'll hit 100,000 in about 2 months, but let's make it be 1 month. Yeah? So what is a floating neutral generator good for? Good question. And that is for connecting to a standby system, or basically connecting it to a power inlet plug connected to an interlocked breaker. I'll put a link to that video at the end of this video for you guys if you want to see how you get a generator interlock kit all set up. But basically, as you guys saw in my video about separating the neutral and ground in subpanels, the whole idea comes down to you only want to connect or bond the neutral and the ground at one location. So that is usually the first disconnecting means after your meter. So you can see right behind me here, there's the meter, and then right next to it is the first disconnecting means. So inside of that panel is where the neutral and ground are bonded together. And consequently, when you hook up a generator to a power inlet box, it has 4 terminals, as you can see right here, and those terminals are 2 hot wires, a neutral and a ground. And since the neutral and ground are tied together in that first disconnecting panel, when you attach this cord to your generator, it essentially bonds the neutral and the ground, but not in the generator, it does it inside of this panel. Let me just show you really quick where that is inside of the panel so that you can kind of get a clear picture of this, and we'll follow this all the way back to the generator. So here we are inside of my first disconnect means after our meter. So our meter comes over and feeds power into this first 200 amp panel. Has feed through lugs down here which feed down and over across into the house over there. But you can see that on the neutral bus we have both ground and neutral wires landing there, and you can see right there at the top there is our green bonding screw that is still installed, and that's basically bonding the frame of this panel to that neutral bus. So all of our neutrals and grounds are connected to the same place. We have a ground rod, which you can see that copper wire right down there goes down and attaches to a ground rod down here. And then if we look at the wires that are coming from our power inlet box, which is right back here is our power inlet box for the generator. Those wires come up and attach to this interlock breaker right there. So we have our two hot legs, and then our ground and neutral wires attach right there, right next to each other. So you can see they're going to the exact same place. So we'll go ahead and get our cord connected. But before I connect the generator, I'm going to install this panel cover back in here so that the interlock kit works properly. Because with the panel cover off, that could allow a situation where you have both the utility turned on and the generator turned on at the same time, which we do not want to do because that could backfeed the utility. Alright, we have our cord connected over there, coming across the ground, and over here to our generator. We don't have it connected yet. I'm just going to show you guys again that right now this is an unbonded or floating neutral system. So we have one prong in the neutral, and then we'll just go ahead and check to ground, and we do not have any continuity there. So as soon as we plug in this cord though, it will create continuity because it's essentially going to be connecting the ground and the neutral all the way back in that panel where you saw that both the ground and the neutral wire connected on the neutral bus. So we have our plug. So go ahead and test from the neutral, which this one is connected to the ground. And you can see right there, we have perfect continuity. Essentially now, this generator is perfectly safe to use and is connected in the exact way that you would want it to be for a generator that's feeding through a power inlet box with a breaker interlock kit. Okay, so to conclude, we are going to go ahead, fire up the generator, and right now everything's set up with a floating neutral the way it's supposed to be, and then we're going to use that appliance cord to essentially create a bonded neutral generator, and we'll be able to measure how much current is actually flowing on the grounding conductor. Since this generator is connected to the very first panel, I honestly don't think it's that big of a deal to have a bonded neutral generator connected. And that's because you saw those two wires were connected right next to each other. So basically, the only place where you technically have current flowing on a ground wire where it's not supposed to be is on the cord going from your inlet box to the generator itself. And even though that's technically not right, technically we don't want any current flowing on the equipment grounding conductors, it's, in my opinion, not that big of a deal. But that's just my opinion. Always follow recommendations from manufacturers and any sort of instructions that are associated with your installation. So let's go ahead and get this generator fired up. We're going to put the house load onto the generator, and then we're going to measure how much current flows on that grounding conductor. So we have our generator in 240 volt mode. We're going to turn the main breaker off for now. It is connected to ground, although it wouldn't have to be, so we do have a ground rod connected. I'll talk about that in a separate video, but the short version is you don't really need a ground rod connected to your generator if you have it connected to your electrical system like we have here. But again, you're supposed to defer to manufacturer instructions, which these Chinese instructions say you're supposed to ground it. So we're going to go ahead and get it started up. And then over at our panel, we're going to switch over to generator power. So in order to do that, we just have to turn off our main breaker feeding the property, like that, and then pull up our locking plate and then turn on the generator. Now you heard the generator kick in there, so we know that it is now supplying power to the property. I'll grab my phone and we'll take a look at the Sense energy monitor to see how much power is currently being drawn. Okay, you can see right now we're using 485 watts. So not a whole lot out of our total 3,500-ish watts that we could use. So what we're going to do next is we're going to take our cord here that we were using earlier for simulating our basically bonded generator, and we're going to go ahead and connect this, and then we're going to measure how much current is flowing basically on the grounding conductor instead of the neutral. So we'll go ahead and get that connected. So plugging that in didn't change our wattage at all, but now we probably have some power that is flowing on that ground wire. So we'll go ahead and check that now. So we have our meter in amps alternating current, and now we can measure how much power is running through that ground wire. So we have 0.16 amps running on the ground wire right now. I think what I'm going to do is I'm going to turn on a couple more loads and see how that changes it. So I turn on a few more loads, and you can see right there we're drawing 1.28 amps that's flowing on our ground wire back to, or I guess it's actually coming back to the generator. It's coming back through there and ultimately combines on that neutral bar and comes back on both the ground wire and the neutral wire to the source, which is what we're trying to avoid, and that's why having a floating neutral is better for this particular situation. I realized I didn't actually film a proper outro for this video, so here we are. It's the next day. It's actually Sunday morning right now, Father's Day, so happy Father's Day. It is about 7 a.m. You guys are going to be seeing this video a little bit later today. But that pretty much summarizes the whole bonded versus unbonded neutral or floating neutral in generators. So if you guys want to understand more about neutral current, I made a video that kind of covers that pretty well, so I'll put that link right here so you guys can see that. It kind of goes through why neutrals and grounds are separated in subpanels and how you keep your neutral current from flowing on your equipment grounding conductors. Or if you want to see the video that YouTube thinks you want to watch, click on this video right down here. Thanks a ton for watching, you guys. If this video earned your subscription, make sure you hit that subscribe button. And we will see you guys next week. I think I'm going to put up a video about